Hello, my name is Tim, and I'm a developer advocate at Dagster Labs. And as Colton said, welcome to the next Dagster Deep Dive, where we talk about a part of Dagster, what it is, why we like it, and how we like using it. And if you haven't seen Colton's or Pedram's previous talks from last month, they're on the Dagster YouTube channel. But today we'll be talking about partitioning your data and what Dagster provides to help manage these partitions. Now, if you're not familiar with Dagster, Dagster is a framework for orchestrating data pipelines. You have the flexibility to build pipelines outright or create a platform to enable others to build their own pipelines. And as a framework, Dagster is grounded in having strong core building blocks to build the data platform you need and not feel restricted in what you can do. And today in particular, we are going to go into detail on one part of those building blocks, which are partitions. We'll cover the fundamentals of partitioning your data, how to think of your data pipelines in partitions, and how Dagster's APIs can help support that. Let's get started by talking about why you'd want to partition your data in the first place. Now, data pipelines often scale linearly with the size of your data, which includes increasing runtime and costs. And this is because many people's data pipelines rebuild their tables or reports from scratch with each run. And this means that for every new record you add to your tables, your pipelines will just be a little bit slower and a little bit more expensive. However, over time, this stacks up. And there are some very heavy implications for this. If you're not on top of it, you'll eventually start missing SLAs and expectations for when your stakeholders need your data. Or you'll have finance reaching out, asking why your bills are just always constantly growing. So how can you break the relationship between your growing data volume and the resources your pipelines take? And is there a world where your resources have fixed costs and aren't as tightly associated with how much data you have? Thankfully, this problem has existed since the beginning of data analytics. And one of the best solutions found was to incrementally load your data. This is the process of working with data that has not been loaded yet. This means you don't redundantly load or transform data that you've already properly worked with and are only spending compute resources on new data. Therefore, you'll only be working with records that might have been added in the past week, and you don't need to redundantly transform data from 5 years ago. And partitions are a way to model incremental data. Rather than working with the entirety of your data, you're only working with an individual slice of it. And these slices can be defined by any shared dimension or feature of the records. There are two different types of dimensions to partition by: continuous and categorical data. Continuous partitioning is bucketing based on a range of values. The most common continuous type of data to partition by is time, such as transforming an individual day, month, or year's worth of data. However, you might be receiving data from different locations, such as warehouses or satellite offices, or a team might share an Excel file with you on a SharePoint drive whenever they have a request. Situations like these are good candidates to partition your data categorically with. And if you've experienced the strain or pressure that we talked about earlier when working with this quickly growing data, then you should consider partitioning your data assets. The great thing is, Dagster has native support for partitions as one way to maintain incremental data assets. And for the rest of this talk, we'll go over some of the many ways this is available to you and how you can use partitions to make robust and efficient data pipelines. All right, so in Dagster, a partitioned asset is a collection of smaller assets that share the same definition by having the same function to materialize it, and by also having the same dependencies. These smaller assets are all similar, except for which partition they're responsible for. Here's a small portion of the different classes and functions available in Dagster to help you manage partitions. This will also serve as a brief preview for the rest of this talk, so you don't have to memorize everything you see here. First, if you can partition by discrete data, then maybe you can use static partitions, which takes a list of which partitions you want. Or with the dynamic partitions, you can organically make new partitions as new files are added to a directory or new possible values are made in a categorical column. Then we have the time-based continuous partitions. Out of the box, we have 3 time-based partition classes, which are daily, weekly, and monthly grained. However, if you have a more bespoke time range, you can define your own partition with the time window partition definition class. By passing a cron schedule to it to define the ranges, you'll define your own time-based partitions based on that, such as quarterly, semi-annual, or yearly partitions in this case. And then once you define your partitions, you might want to customize how downstream assets use the partitions they depend on. We'll talk about some of these APIs later on. And then you'll need some way to figure out how to access your partition when materializing your assets, which is why Dagster exposes a runtime context argument for your code to know which partition it is trying to materialize. And now that you've seen some of the APIs, here is what a partitioned asset looks like in Dagster. There are 3 parts to this. You first say what you want to partition by. In this case, it's by these 5 categories: electronics, clothing, books, home, and sports. Then you partition your asset by adding it to the asset decorator's arguments. And then when executing the shared code to materialize the asset, you access the partition key that the run is supposed to materialize. Here, we're first logging what partition key we're trying to materialize. Then we're using the partition key as an input to our business logic to know which category we are trying to build. And the difference between the function body of a partitioned asset and an unpartitioned asset is that a partitioned asset is typically only supposed to materialize one partition. And when each partition tries to materialize, the same code is executed for each of them. The result of this is being able to build an individual small asset for each of the categories. And these pieces can be run individually and can scale as you add more categories of items. And this is typically stored as a one table in your data warehouse, allowing you to build parts of your table in piecemeal and not have to build everything at once. Cool. So let's go ahead and run a project with some partitioned assets. Well, I'll drop a link to the repo for this project later on, but here is our Dagster UI and a quick little project that we have. And you can see how we have a set of tables that are represented as assets here. We have some dimensional models over here and some metrics over here. Let's click on this dim items asset over here, right here, and take a deeper look into it. We're going to open up the page for it and be taken to the Partitions tab. We'll only see this tab for partitioned assets. Here, we'll see the 5 categories that we just defined earlier, along with their status. Gray means it's never been materialized before. Red, if it was there, means Dagster failed trying to materialize it. And green means it's been materialized successfully. There it is. And how about we fill out some more of these partitions? How about we backfill another partition? And backfilling is the process of running historical partitions and can be done programmatically or from the Dagster UI. By default, Dagster will kick off an independent, isolated run for each partition in a backfill. But this can be configured to execute in a single run if you need it. Now, usually, pressing materialize in the Dagster UI will go ahead and materialize the asset for you. However, if the asset is partitioned, then you'll get this little pop-up first. This is because Dagster needs you to specify which partitions you want to materialize. Now we can click on the dropdown and say which partitions we want to build, such as, well, all of them. And for convenience, you can also check this box to filter down to just the partitions that haven't successfully materialized yet. This is definitely helpful if you have hundreds or even thousands of partitions. But for the sake of time, let's just try materializing one partition. After selecting a partition and clicking launch, let's give it a couple seconds and we can look at the run that was kicked off. And here you'll see that partition getting materialized. And if you look at the logs, you'll see that our log statement from earlier says that we're materializing that specific partition that we wanted to backfill earlier on. This is because our code has access to which partition key is trying to materialize. And then once you head back to the asset graph, you'll see that the node for the asset should now reflect the current state of all of your partitions. In this case, we have 2 materialized, 3 that haven't been materialized yet, and no failed partitions. All right, let's flip back over to slides. Now that you've seen a categorical partitioned asset in code and in the Dagster UI, let's look at another asset. But this time, we'll partition it continuously by time, which is a very common use case for people. Here is a very simple fact orders asset that has its business logic abstracted out to a separate module. This fact table is growing fast, and it's incredibly costly to build every month. Let's pretend that it takes like 25 hours to run and costs $500 to make each time. We want to partition it by month then. And to do that, we'll walk through the steps that we highlighted earlier. First, let's import the partition we want to be working with. In this case, we'll import the monthly partitions definition class. Then we have to make an instance of this class. When making the instance, we have the opportunity to configure this partition. For example, we are setting a start date for the first point in time we want to partition. But we can also provide an end date if we want to, or even an offset, so your partitions can ignore incomplete months. Then we'll add the partition to the asset decorator. This is the same as before, but this time we're using that monthly partition we defined. Afterward, we update the asset's logic to factor in this partitioning. And with partitioned assets, the patterns and functions you use to work with may vary by what you're partitioning with. For example, you might need a way to get back a range of dates if you're working with continuous data, or you may just need one string value to represent the category you're currently materializing. In this case, we can access the partition time window property from our context argument to be given a start and end date of the partition range we are trying to materialize. And there we have it. Now we have the inputs needed to know which partition we are trying to build. And we just pass that into our business logic to use it and filter down our data. Now let's flip back to the Dagster UI and see this in real life. Here, you'll see that fact orders asset in our asset graph. If we click into it and view its page in our asset catalog, you'll be taken to the Partitions tab once again. This will look mostly similar to the categorical partitioned assets tab, but this time we'll have all 50-ish partitions, one for every month since our start date. You'll also see the status bar towards the top of the page. Here is a visualization of our partition states. Same as usual, green means materialized, gray means it hasn't been materialized yet. And then once we try materializing it, we'll be taken to the backfill modal once more. This time, we also have this selector in the UI, so we can pick the range of partitions we want to materialize. And if we click on the launch button at the bottom right of the modal, that'll kick off a run for our partition. You can see that this one's in progress right here. Let's click on the run. All right. And if you look at the logs, you'll see that rather than getting an individual key for the category, like we did before, we're instead given 2 timestamps that we accessed earlier. the start of the partitions range, and the end of the partitions range. If you'd like, because of the continuous nature of this data, you can even configure this to materialize multiple of these partitions in one run. All right. Cool. Let's take a second to do a brief little recap before moving on, because I know this has been a lot. All right. A partitioned asset is a collection of smaller assets that share the same definition. A partitioned asset, and then partitions can be defined by any dimension the smaller assets share. And you can use the static partition definition for categorical data, or you can use things like daily partitions or monthly partitions for continuous time data. And here's our current state. We have two assets, one partitioned by category and another partitioned by month. As you partition more of your assets, you'll eventually create assets that depend on partitioned assets. And this dependency might have some custom nuance that you need to be expressed, which is why Dagster has partition mappings. To define these relationships between assets and the upstream partitions it might depend on, Dagster provides a configuration called partition mappings. This lets you express dependencies, like depend on all partitions of its parent, which is useful if you have an unpartitioned asset depend on a partitioned asset. Or depend on the same partition as itself, if you have two assets that are partitioned the same way. Or you can depend on a specific set of partitions, such as one weekly partition should wait for its upstream's 7 days of partitions respectively, and so on and so forth. Here is an example of how you can express this dependency. Here, we want any partition of fact orders to use all partitions of dim items. To configure this dependency, let's import the asset dep class from Dagster. Then we'll wrap the dim items dependency with this asset dep class. By wrapping the dependency, you can fine-tune how fact orders uses dim items. In this case, let's import the all partition mapping class from Dagster and use the partition mapping argument to define that we want any partition of fact orders that is materializing to depend on all partitions of dim items. And that's all it takes to define this relationship. But let's look at a slightly more complicated example. Here you have three assets. From right to left, we have a monthly partitioned asset that depends on a weekly partitioned asset that depends on a daily partitioned asset. In this case, there are some relationships that we can leverage. For example, we know that a week is 7 days and that a month is a little fuzzier. It's like 4 weeks and some change. Out of the box, Dagster isn't going to assume you need to care about this, but if you do, it's pretty easy to say so. We can use a different type of partition mapping called a time window partition mapping to say that we want to make use of the relationship between these different granularities of time partitions. Once again, if we wrap the partition dependencies in the asset dep class, we can configure this dependency to say that these time-based partitions should depend on their finer or coarser grained respective partitions. And here it is. Here we have the assets automated to materialize as needed. And as the fine-grained daily partitions materialize, weekly top items will realize that the days it needs are complete, and then build the partitions for all full weeks that it has available to it. And then the same applies for the monthly top items asset once its dependence weeks are done. This is one of my favorite combinations of Dagster features, and it's always exciting to see this in action. If you want to get this running on your own computer, feel free to check out that repo that I have pushed out for this and try running it yourself. All right, let's recap what you just covered. Partition mappings configure how an asset depends on a partitioned asset. And you have many mappings available to you, such as all partition mapping to say, yeah, just use all the partitions, or time window partition mapping, which lets you roll up or drill down into different time-based partitions. And there are a couple that we didn't really dive into, but are worth covering, such as identity partition mapping, which lets you map one-to-one the same partition across two assets. Or last partition mapping, which lets you depend on just the latest partition in the sequence, such as the most recent day or most recent week. And that's the end of today's deep dive. If there is anything I want you to pull away from this with, it's these three things. Partitioning data makes pipelines faster and cheaper. And by working incrementally and only transforming slices of data, such as the most recent, you will work with less data and your pipelines will be more efficient. And Dagster has great native support for partitions. As said in the beginning, as a framework, Dagster is grounded in providing you strong core building blocks. And one of those building blocks is Dagster's support for partitioned assets. In the past half hour or so, you saw how Dagster gives you a large toolkit to fit every situation you may need, such as partitioning categorical data with static partitions, or time data with time window partitions, and appropriate properties accessible at runtime to merge your business logic with Dagster's orchestration. And lastly, you can configure how assets depend on partitions. You saw a couple different partition mapping examples where a downstream asset can depend on all partitions of its parent or a specific set, such as 7 days worth of partitions. And that's it for today. If you'd like to chat with us, feel free to join the Dagster Slack. If you want to try out Dagster in a production-like setting, you can use Dagster Cloud, which is free to use for the first 30 days. If you like this talk, you can sign up for our newsletter to be notified of future talks and other Dagster news. And we are inching very, very close to the 10K GitHub stars mark. So if you like what we're doing, please give our open source project a star in GitHub. And thank you for your time today. If you have any questions, feel free to ask them in the chat. Colton and I will be here to answer them or help you find the right person who can. Thank you.
Thanks so much, Tim. We do actually have a few questions in the chat, so we can try to address those, and we'll see if anybody else has any questions too. The first one was from Andy, and he was asking, how can you limit the number of partitions, for example, the last 90 days, to prevent them continually growing without bound?
So if you want to look at the past 90 days, I mean, you can have it, it depends on how you have it growing, because it sounds like, it's possible to just have the past 90 days, set your start date, and then never need to backfill any partitions outside of those 90 days. So I'm curious to see what your use case is that may have it so that these partitions constantly keep growing and that you need to clamp it down.
Yeah.
Because I think in a lot of situations, having a start date and an end date should be able to satisfy this. And that start date and end date can be programmatically set on deployment. So you can template that in. I think Colton might have mentioned that in the comments.
Yeah, exactly. And it looks like Andy said one of the problems was more on the UI side of things, where when you have a lot of partitions, if it's hourly, for example, it becomes a little bit difficult to wield. So I think that's a good point, Tim. Like if you have this start date more programmatic so that it updates on a new deployment, that will clean things up. But also it's valid feedback that the partition UI could get a little cluttered, and that's something that we can look into more, Andy. Cool, thank you. We have another question here from Jacob. He said, in the fact orders scenario, what happens if you create a new partition in the child asset, the one with the static partition? Would that make all the fact orders incomplete, or would Dagster ignore the addition of the new partition key in the child asset?
It will, okay, so Dagster has a concept of like a data version and a code version for each asset. Given that you have a new partition upstream of it, your existing partitions won't be it won't suddenly say that these partitions have failed, but it will say that like, okay, well, hey, like your upstream dependency has changed a little bit. What is true isn't necessarily true anymore. So that it gives you more of like a prodding warning that like you might want to try like re-backfilling these assets if it's upstream changed.
Right, great. Right, we have
Thank you.
another question. Sorry, did you say something?
Just thanks.
Oh, nice, no problem. This next question is there or any plans to add hierarchy in categorical partitions, either static or dynamic? For example, if there are inherent groups in dynamic partitions, I would like to only backfill a specific group if needs arise, in a similar fashion to how you would only backfill the past 90 days. So yeah, the question is, are there plans to add a hierarchy in categorical partitions?
I can't necessarily speak to product roadmap, but what I have seen is if you have granular enough partitions in which you can create a hierarchy out of it, then you might benefit from breaking it down into two sets of assets. One of which is a static partition asset with your categories and hierarchy, and then another asset downstream of it that depends on it, which is I didn't cover it because I figured it would go away over time with it, a multi-partitioned asset, in which this multi-partition asset is a combination of two different assets. So you can have your finer grained, or you can have your multi-partition depend on your static partition and have that first partition for that multi-partition be that static partition. Therefore, like giving you that little hierarchy. And so if you need to backfill an entire group of partitions, you could like backfill the static one, and that should update the downstream relevant multi-partition ones, or at least mark them as out of date.
This one might have been answered already. I'm not sure. The question was, how do we partition by time and category? Also, can we partition by 3 or more dimensions? Multi-dimensional partitions are definitely a thing. Tim, I don't know if you want to talk to it a little bit more.
Yeah, multi-partitions are that opportunity if you want to combine different partitions together, such as if you have categorical, and you want to combine of time. Like for example, if you want like by month, by like warehouse or something, that's a very common one. I don't believe there is current support for having more than 2 partitions for a multi-partition. I also can't speak as to like its priority on the roadmap, but it's feedback we've heard before, and we're taking note of it.
All right, maybe we'll take 2 more. So we have a question from Alex that says, can you dynamically create new partitions partway through a run? Say top level partition A is defined in a run, and after reading some data, I want to have partitions A1, A2, A3, A4, A1, A3, A4, but not A2, based on some initial data that has been processed. So to reiterate, it says, can you dynamically create new multi-partitions partway through a run?
Not partway through a run, I believe. I mean, you probably can. I wouldn't recommend it though. But in this case, yeah, I would probably. I'll say upfront that like this is something that we can dive deeper into outside of this call, but something you can do is have a sensor that creates a new dynamic partition as these new smaller ones come up, or as these new partitions come up, and then kick off runs based off of that is probably what I'd recommend, just to have a cleaner architecture rather than like creating new runs as you, or rather than adding steps onto your run as you're going along.
Okay. Fraser pointed out there are also some questions in the Q&A, not just the chat. So I'm going to take one of those. So Gabrielle said, partitioning looks like the right fit when you're doing batch extraction. But if I'm working with CDC data, I think there is no point in creating partitions for change sets. How should one leverage partitions in cases like this? That's a good point, Gabrielle. So I don't know if partitions are necessarily the right solution for this. I've worked with CDC data in the past, and it's more of like a streaming solution where you have batches of data that's like loading on S3, and then you want to take those like inserts and deletes and reconstruct the downstream table. You could potentially have partitions by day there or hour. For example, you're getting CDC events for the past hour and you can reconstruct those. So I think maybe a temporal partition might make the most sense. But yeah, working with CDC data a lot of times lends itself to streaming or yeah, some kind of like temporal partition.
I'll
Thanks, Kit.
say that, like, yeah, if it's CDC data, you're streaming it in. Don't try to force a square into a circle hole or whatever. But that when it comes to a lot of data pipelines, everything is streaming until it's not. And so, like, you may reach a case in which further downstream, it turns into a batch process. And if that's the case, then like you can use partitions as an opportunity for it.
Cool. All right, two more, I promise. This one from Philip says, if I use dynamic partitions, for example, a new client is a new partition, and then I want to run parallel processing and create dynamic partitions for each order of this client. So for example, one partition at start and add a new dynamic partition in the future. Can I do that? They tried to do, they were not able to, they were not successful in setting up dynamic mapping for that. So to reiterate, I want to run a parallel process and create dynamic partition for each order for this client. Do you know, Tim, for that one?
This one's a little tough. I would say, like, we might need to see some more code for this and some additional context as to what's going on. But
Sure.
yeah, it's but this use case is a really common one in which we have plenty of like consultants or places with a discrete number of customers, and they'll have a partition per customer. And then like as new customers onboard, they'll like query a table to make a new dynamic partition for it.
All right, and last one, last but not least, let's see. Pierre said, given I have 3 assets, each computed differently, but sharing a common data format, and one downstream asset depending on all 3 of those, say I want to modify this downstream asset to be partitioned. If I create a static partition with 1 partition per upstream asset, how can I map an asset to a specific partition? So I could only run the downstream partition corresponding to the changed upstream asset.
Given I have 3 assets, each computed differently, but sharing a common data format.
This might be a good time to point out that we also have the Scout AI integration in our Slack channel where you can ask it questions and it's trained on all of our documentation and example code, and it can often give pretty darn good answers. So I would suggest also trying that out if you have the time. I don't know if you have anything else to say on that one.
Yeah, this is also a more complicated one, and I would say that typically I would wait with a static partition with 1 partition per upstream asset. I would be curious to see how to do this without partitions actually, since it seems like a fair mapping between just asset to asset and its dependencies. But yeah, definitely Scout AI, pretty good opportunity. It's been great. And when it's not great, Colton, I, Pedram, and a couple other of us are there to like chime in and update it or just give feedback to it. So it's good and it's constantly getting better.
Great. Well, thanks again, everyone, for attending. I wanted to remind you that there will be 2 more sessions in this deep dive series. Session 4, hosted by Pedram, will be on integrating third-party systems. And session 5 will be Tim again on enabling data mesh. I just shared the link there for you to sign up for those if you haven't already. And I believe that's all we have. Thanks again. Any final words, Tim?
No, you took them straight out of my mouth. All right. Thank you for all of y'all who attended and stayed. Appreciate this. Yeah, if you have any questions, feel free to ask us.
Thanks so much.
Offline. See ya.
Have a good one. Bye.